And it's the hardest question that a being can ask themselves, right? Why do I exist? It's easy for me to pick up an object and say, why does that exist? But why do I exist? Life is about persistence from existence. So you produce a thing that exists, great, well done, but then it has to persist long enough to be effective to do something else. We have been totally misunderstanding how reality works. I want to discover what selection is in the same way that Newton discovered what gravity is. I don't really care about the origin of life. I think the origin of life is a boring problem, but not inconsequential. I think the problem is, what is the process that gives rise to life in the universe, full stop?
Your thinking covers a lot of subjects, from artificial intelligence to chemistry to aliens. And I'm wondering what ties all of these things together for you and how it all got started.
Yeah, the problem is I keep remaking the question, right? But I think the most faithful answer I can give is I'm really confused about why we're here. If I think about myself as an entity in the world, I remember when I was a kid looking at the shoots coming out of the ground, and I was growing vegetables, or the sun coming through the trees. I was just like, what on earth is going on? I didn't know I was allowed to ask questions about science. And so when I realized that everyone else is in that delusion as well, I felt a little bit better. But I mean, life is kind of wacky, right?
Mm-hmm.
So I guess, so I started up like that. And I'm obviously, I wanted to code stuff. The computers were coming. I grew up in a time where all my colleagues, my friends had computers. And so I started to kind of play around with these, and I had some kind of idea of how I could manipulate, I suppose, a calculator in a more than a boring way. And I was just fascinated by biology. It's like, why do things grow? Why am I here? Why do I think? What is the, how is it that I have options? Because physics, I got given this book that told me about physics, and physics told me I didn't have options. But suddenly I realized I had options, and that seemed to be completely counter to physics. And that was very confusing to me, that I had options and physics said no.
When you say that you're confused about why we're here, I just want to clarify what you mean by that. Is it more a question like, what is the purpose of life? Like, what is your purpose in existing here? Or more a question about what is it about how the universe is put together that has allowed for us to exist, or made it, if you want to put it this way, inevitable that we've come to exist?
Oh, oh, that's so. No, I mean, I think I'm kind of like, I'm a simpleton when it comes to that, and I'm just like, why do I exist? Like, I'm an egotistical simpleton. I mean, I exist. Look at me. I can go around and just create mayhem, and then I create mayhem. I was like, oh, how did I create mayhem? Um, I mean, I've been around long enough now to discuss with people about their views of the universe and their ideas. And I mean, that's so far beyond my paycheck. I just prefer to say, what's going on here? But what I found in the last, I guess, the last 10 years or so is that my simple approach basically met the people with the large paychecks in the middle, because my questions, their questions seem to be the same thing, which I found very exciting and also a little bit depressing. Because I thought, I have no, if you take the kind of like the idea of what gravity is or electromagnetism, and the thing about the history of it. I mean, what I'm asking right now is, why am I here? Not in in a kind of metaphorical sense. I'm asking, why does biology exist? I'm a chemist. I'm a chemistry professor, and I'm trying to understand, why does biology, with all its chemistry, exist from the chemistry I know? And the gap is so big, I found very interesting. And that's one of the reasons why I've kind of dedicated my life, I guess, to some degree, because I'm so confused, to asking that very simple question: is what turns sand into cells?
I really like the way that you put that. And it sounds like the question then that most interests you is what is the origin of life from a chemistry standpoint? Is that accurate?
But not just the origin, because I think the origin is quite boring because it's quite, um, circumstantial. I view it, if you imagine that we have gone a few billion years, we look up in the sky and we see no stars, just black, and we see the sun, and we say, "Oh, what was the origin of the sun?" But if then we imagine, we say, "Oh, what we see the sun, but you see all the stars." And so when people ask me about the origin of life, I don't really care about the origin of life. I think the origin of life is a boring problem, but not inconsequential. I think the problem is, what is the process that gives rise to life in the universe, full stop. And if you look up and I'm just imagine, if you look up in this night sky, where we're in my workshop just now, there's out there is a big little kind of dip where it gets really good light. And I did a lot of astrophotography during the pandemic. And it was really fascinating because you could look up in the sky and go, okay, these stars, if I look up in any one night, if I get lucky, well, I never saw this, but I can imagine a star dying and a star igniting. Because right now we're just asking what gave rise to the sun, to life, but we're not recognizing the fact that that stars are born and die every day in the universe. And what I want to know is not just the origin of life. I want to understand the actual process that gives rise to biology every single day in the universe. And that's kind of a radical statement because I'm like assuming that biology is everywhere. And I think that's probably that's not correct, but that's kind of my starting point, if you like.
Okay, no, interesting. So just again for my own understanding, you find the question of the origin of life on Earth to be boring because it's just something that maybe happened once. But what's more interesting is what is the general principle what are the general principles of chemistry that allow for life to come into existence across the universe?
Yeah, absolutely. That's it. I mean, that's for me, for as long as I can remember, I was like completely confused. I mean, I times dissect this a lot when I'm talking to people about why am I doing what I'm doing, and I am remarkably confused about why we are here, and I have been that confused since as long as I can remember, and I think that's the question: what is the physical process? The physical process gives rise to life. In the same way, what is the physical process that gives rise to the sun? The process I know that gives rise to the sun is nuclear fusion and gravity. So hydrogen falls together, gravity increases, energy, the temperature increases. There will be a point where the temperature is such that you can break the strong nuclear force. A fusion occurs, the thing explodes. There's so much gravity it doesn't fall apart. You got this kind of like this two things working together. You have a sun. So I want to know. Life is about seemingly doing lots of chemistry, lots of possibilities, and not running out of material. So how do these things balance together? And I'm very inspired by that because I think it's the answer, or at least a plausible mechanism where right now we're not asking mechanisms, we're almost being, and I hesitate to say this because I hate the notion, but chemists and origin of life people have been pseudo-religious in their, oh, it was this thing, we work backwards. I'm like, no, that doesn't make sense. As a scientist, I have to ask myself, and it's the hardest question that a being can ask themselves, right? Why do I exist? It's easy for me to pick up an object and say, why does that exist? But why do I exist? And I think that that's something that I'm maybe a bit of I kind of just want to get beaten up over because I get so many arguments over this.
Well, I'm glad that we've taken the time to sort of have this introductory discussion because it helps me think of a roadmap for this conversation because there are two things that I really want to get to, which are artificial intelligence and aliens. And they're not, at least obviously connected to chemistry. But I think an interesting way to go about getting to those topics is discussing, one, what were the maybe dominant theories, if there were any, about these general origin of life processes before you started working, what the problems were with them, and then how your work in chemistry sort of intervened and the path you're on now. But so let's start with that first one. What were or are the dominant theories on how life can come into existence across the universe?
Yeah, so I think most people, I think there's a number of different approaches. First is that people say that life is absolutely unique to Earth. There is no life elsewhere. Which is like I can accept that that's a reasonable suggestion because we don't know of any life elsewhere. And then, but let's just park that for a second. Say, well, why is life here? Well, there's evolution, and there's chemical evolution, and there's a need for certain processes to occur for evolution to break the barrier, but from kind of sand to kind of genetics. And so I think what predominantly people would think about, say, like, the genetic world, or the peptide world, or the kind of, and then the metabolic world. So you've got these kind of different worlds going on, and maybe I would introduce another world which I think is not used enough, which I think is interesting, which is the self world. No, never used that before in any. I don't think exists. So you have kind of like metabolism, genetics, proteins, and self. Now, the self people will be about cells, but I think it goes more than that, because when matter has a self, matter can become alive. So yes, I think this self is very interesting, and I'm not really sure that anyone else has thought about it in chemistry, and I feel a bit lonely because chemists seem to have been put in a box where you just need to do chemistry. And you have the philosophers that can think, and you have the physicists that can compute, and the computer scientists that can tell you're all basically not going to be alive, and the poor chemists have to make drugs so you don't die. Which is kind of depressing, actually. So part of my role is to be a radical and just say, actually, the origin of life is because of chemistry. Everything you have is because of chemistry. And am I a chemical egotist? Oh, yeah.
So then, how do you formulate or go about considering how chemistry or the principles of chemistry should function in this theory for how life begins across the universe?
Yeah, so I think it's very simple, actually. I think if you imagine the universe at the beginning where everything was very simple, and you had some energy, and then energy and matter would combine. And I've been talking about this with my collaborator a lot, particularly Sarah Walker, who I've been working with in Arizona State University, because we kind of came at this at the same time. Where when I met Sarah, she blew my mind because she said stuff and I didn't understand any word she said semantically. But it's like I was like hearing a melody which I understood instinctively. Right? It's kind of weird when you meet someone who's like, because that's what happens when you have cross disciplines. I spend a lot of my time being clueless, and that sounds really cool. I think I get it, but I don't understand the words, but I kind of get it. And the origin of life is a bit like that, because what is life is a really important question. Because I can pick some. I'm in my workshop just now, so my favorite things I've just 3D printed. Like this grid. I'm making a chemical brain with this grid. You can see all the holes in it. This is like a 3D object. I just printed it. It's kind of cool, but it's not alive. It's dead. But it's a living artifact. This artifact doesn't exist anywhere else in the universe. It required a stereolithographic 3D printer. Required me to actually write the code. So when you're coming, what to life is chemically, I think it's about molecules that can survive, or networks of molecules that survive over a period of time, that can actually affect their past, if you like, or affect the ecosystem that produced them, so that they then create more possibility to survive in the environment, because the environment is the enemy. The environment is the leveler. The environment will kill you. Unless you understand how the environment is going to change, you will die. And human beings are good examples, right? A friend of mine I was talking to about it's like, it's become a friend over many years. He's a physicist. He said, if I leave Oxford and I'm not crypt, I will just get dissolved by the atmosphere, run out of fuel and stuff. And I was like, David, that's a bit ridiculous, because you go to the hospitals, but there were no hospitals. And then, so I think molecules that can assemble and form networks that replicate themselves or do something to propagate themselves into the future, that resist death in the environment, is what life is. And there's two words I'll say there. Life is about persistence from existence. So you produce a thing that exists, great, well done, but then it has to persist long enough to be effective to do something else. And I think that's really actually the answer to what life is, in a way.
So first, just a terminological question. You said that this grid that you displayed a moment ago was a living artifact. And I don't think that I think your use of words is probably careful. So I want to ask about it. You think of this thing as, it's not alive, but to me, I would want to say it's an artifact of life rather than a living artifact. So I just want to understand why you chose to describe it that way.
No, I would actually say that your terminology is correct. This is an artifact of life. It's not living because I created it. And so you're absolutely right. But if you think about it, if I was to freeze every molecule in if I was to say, okay, Robinson, freeze, and I was looking at you and I rotate you around, it'd be like this.
Yeah.
There's right. So you're absolutely right. And this artifact is a product of living technology. It's not alive in itself, but it's a part of a living system. And one of the biggest mysteries we're facing is, what is the difference between molecules that are taking part in living systems and the products of living systems? And are they related? And I guess what I was doing is a shortcut saying, yeah, this is as alive as my hair is, right? But this is not autonomous. My hair is autonomous because my body has hair follicles and hair grows. This requires me to go to my 3D printer, put in the STL file and print it. And so I think you're quite right to point that out. And there's a continuum of, abiogenesis, life, and then technology, which this is. And this is not standalone. Technology is intrinsically connected to life by this process. So I think that's a very nice way of putting it. So thanks.
Well, another question then, maybe this is a good way to help me understand a bit more what you mean by matter comes alive when it has a self. And what's the difference, or where do you locate the self in the hair follicle that's not there in the grid?
Oh my gosh. I think the self in the hair follicle is 4.3 billion years old. And I think actually the grid here, this is also 4.3 billion years old. You just can't tell by looking at it, right? If you were to say, oh, this doesn't look like it's 4.3 billion years old, it's a grid, few bits, it's not that complicated. Whereas if you looked at the hair follicle and the genetics and what was going on, you would require this lineage going backwards. And this is the biggest mystery of life, in a way, that we are still grappling with this understanding of, if you look around you, I mean, if I'm in my workshop just now, there's crazy things everywhere. These things are the most improbable things in the universe, in a way. And so these improbable things are created by humans or living systems as a technology. And so in a way, the way I look at it is you have this kind of inorganic dead matter biology, or the origin of life, then single cellularity, and then going all the way up to memes and technology. And the meme cannot exist without the biology, which is kind of wild, because people are, there's this meme, but it's all layers. This grid although it looks simple, could not exist without 4.3 billion years of evolution. That's radical. Like,
Mm-hmm.
that really can't exist. People say, oh, there's an argument it can, but it can't. I mean, it required me to make it in my 3D printer.
I think Sarah and I disagreed a bit about this, and it sounds like you might too. I mean, I think it can exist without life, at least if our theories of physics are correct in the form of like a Boltzmann grid, something to that effect.
Um, no, I mean, I think your discussion with Sarah was really inspiring because I think you got to a lot of the nuances of what physics can do, what chemistry can do, what biology can do. I really thought it was fascinating. And so I think that we have a blind spot right now is that we have all this stuff around us. Like I have so many interesting objects I can pick up around me. Like, oh yes, my favorite thing here I've got now. I found this is this cartridge called Open Drop. It's a microfluidic programmable device. I can just put droplets around. Sure, a Boltzmann brain could come up with that, but it really required a human being to design it. And the back has got a see-through back. Look at the technology in the back. All those microprocessors in the back there. They don't appear from nowhere. And so whilst I'm really sympathetic to your view that things can spring in, what I realized in my work with Sarah is like, that's impossible. And I think that we have been totally misunderstanding how reality works. Probably since the Renaissance. Or maybe, actually, no, back to Aristotle, which is kind of a wild claim. And given I'm a chemistry professor who doesn't have any philosophy and is arguably quite poorly trained in all things, I'm kind of hesitant. But what I would say is that what controls so if you go back to the grid, this is super simple. It looks like a simple grid. You can do an X, Y, Z here, right? It's a grid. You can make a cube. Great. Fine. Who wrote the grid? Where did the material come from? How was it fabricated and what time and energy to have available? And then once you did that, what technology gave rise to that? And what technology gave rise to that? And what technology gave rise to that? And you end up back at the Stone Age. And so my argument is that these technologies are contingent upon prior technologies, and we are totally, or the vast majority of people looking at them are unaware that technologies we use today are the product of not just evolution biologically, but technological development over time. If you woke up tomorrow and every lithographic, every fabrication facility that gave rise to silicon chips was erased, and everyone said someone just taken them away. Say, sorry, Lee, sorry, Robinson, no more chips. Cope with the chips you have, but you're allowed to come up with a new process to make chips whilst these chips are alive. That would be amazing because humans would go, oh my God, we've got to basically redo all this technology. It's like, and so we do not understand or correctly quantify the lineage of technology that goes from one stage to another. And that for me is totally wild. As a chemist, it blew my mind when I realized the dependence of one chemistry set on another was this thing about how time and contingency work together, if that makes any sense to you.
Well, I don't want this conversation to depend too much on Sarah's, but one other thing that comes to mind, since you brought up memes, we've been talking about the self, and then your story of sort of replication and persistence, reminds me of the selfish gene hypothesis, which Sarah thought was a good narrative, but didn't have too much experimentation really to back it up, if I recall correctly. I don't want to put words into her mouth, but it does sound somewhat like it resonates with your own theory of what life is. So I'm wondering if you think that's fair, or if you think it's wrong in some significant way.
Is the selfish gene wrong in some significant way? No, I don't think it's wrong, but I think it's very much a collapse of a high dimensional problem into a low one. And I think there is so much more going on. So what I mean is that matter has to make this transition from this maelstrom of grey goo, if you like, or just atoms and energy. I mean, if you think about it, go back to the origin of the universe. There's hydrogen, where the go both matters, plasma, gluons. Suddenly you have hydrogen, and if you adopt that approach, you have the hydrogen produced after the Big Bang. The hydrogen collapses, produces stars. The stars burn through their fuel and explode and produce higher elements. Those higher elements do something that is the biggest transformation in the universe ever. They bring in combinatorial diversity because you can make lots of different bonds. That transition, when the first stars exploded and dumped combinatorial stuff into the universe suddenly became big. We all thought the universe is small. It's big in space, but actually we don't understand space correctly. No one I know does. I understand space, I think, probably not as wild as some crazy professors out there, but I think the universe, in terms of causal space, is small. It's only when it made chemical bonds and matter and elements that we suddenly were able to make stuff happen. And so the selfish gene is really very late in that process. The selfish gene does not correctly capture the other things that had to happen to get there, but it does correctly capture this nuance that matter wants to persist in time. So I don't think it's wrong. I just think it's super well defined for a particular part in its timeline. I remember talking to Richard Dawkins about this, and I was like, that's really great. Like, you nailed it. But what happened before? And he's like, I don't know.
So it's very fuzzy. It's toward, as you put it, toward the end of the timeline, and it kind of jumps
Yeah.
over this step from primordial soup to replicators. And you're
Yeah.
interested in the chemistry that arises when you have this big combinatorial space, but you don't have the replicators yet, and you're wondering what facets of chemistry lead from soup to replicators.
Yeah. I mean, if I was to put money on it, I would say that the emergence of life is this, or the emergence of complexity associated with life, or selection, whichever word you want to give, because life is extreme. Actually, because we'll say aliens everywhere. I don't think that necessarily, but the fact is that stars are all over the universe, and I think the selection, wherever there's energy and matter, there's selection. And so what I'm beginning to realize is selection is everywhere, and you just need matter and energy, and you're going to get evolution in the end. For me, that's radical but obvious. And it allows us to remove this anthropomorphization that we have on Earth and our local solar system. And we need to start looking in our universe for evidence of selection beyond what we expect for the M-class star. And with James Webb and other things, we're going to do that. And I think it's fascinating. But I do think we are at the precipice of, I mean, we understand the chemistry. Sorry, we are at the precipice of understanding that gravity operates in the entire universe. I don't think a single physicist who's in this will go, no. I think we're going to be not that far away from understanding that chemistry and biology, or the chemistry gives rise to biology, is present everywhere in the universe, and there's biology everywhere. And this idea that aliens exist, great yes or no, it's kind of a bizarre question. I argue with people about this a lot. It's like, we accept that black holes exist and we've never seen one. We are life, and we basically go, as life exists. No, you're looking at it wrong. Does heterogeneity in matter exist? Does selection exist? If those two things exist together, you will have life. Whether it's complex, whether it produces TikTok or whatever meme you want, or YouTube, I don't know. It'll be different. But the fact is, with these features, you will have life in the universe. It is not optional. It just is what the universe does.
I'm with you. I mean, I think it depends. I mean, it's an empirical question about that will depend on how big the universe is. But I'm with you that it seems much more likely than not that there is going to be lots of life out there. A lot of it might depend on if we're going to be really parochial with regard to what we define life as. Does it have to be carbon based or something else? But before we talk about those questions about aliens, I want to go back to this fuzzy part of the selfish gene theory. And I want to ask, so in the lab you have access to this primordial ooze. You have a bunch of chemicals that you can synthesize or collect, but we haven't, as far as I'm aware, created uh, something that everybody would agree is artificial life in a lab. So what I'm wondering is what the current status of experimentation and theorization is in this field, and where your work is fitting into it and bridging this gap.
Yeah, I mean, I never wanted to work in origin of life. Actually, it's kind of weird, right? I wanted to solve life. I think it's one of the reasons I started collaborating with Sarah. Actually, it's like I found the origin of life extremely hard work because you had all these practitioners who had these requirements, and I was like, I didn't know anything. I was like, why don't I just basically put a load of chemistry in a pot, heat it up, and see what happens? So I think the major issue with the origin of life is that people have preconceived ideas. And if you say to someone, so what look for the origin of life? Say, great, okay, what is life? And if they can't adequately give you an answer, it's like, if you can't give me an answer to what life is, how can you look at the origin of it? So they might say, okay, well, look, I'm going to just take what I know on Earth, right? Just take DNA, RNA, proteins, whatever, cells. I want to look at those. I'm like, how would you know that? It's a bit like me saying I want to look at the origin of music, but look at Sony mini disc. I'm not sure if your listeners, viewers, whatever, know what a mini disc is, right? Or a vinyl record or Spotify. But everyone knows music when they hear it. And so I found that really quite dumbfounding. And as a chemist, it's like, what is, I guess it comes down to this, can we define what life is rather than obsessing about what we think life is because we see it now? And I think that's something we're starting to crack. So I that's one of the reasons I'm not an origin of life researcher. I'm characterized as origin of life researcher. I've debated with religious creationists calls me an origin of life researcher. I beg your pardon. I'm just a chemist who wants to know how sand turned into cells, and I believe, and it's becoming beyond a belief, because for me, belief is something I do not have proof for. I'm not, as I have a lot of religious friends I talk to, and they're like, and people I talk to are not religious say, how dare you debate religious people? I'm like, no. Science is here, religion is here. They do this. They never touch, but they get very close together. And that getting close together is actually quite useful. So I think that people do not understand what life is. They are they anthropomorphize too much. They put too much weight on what they know, and they don't think generally enough. And I think that is very frustrating. And ever since I was like, as long as I can remember, I didn't care about any of the fluff. I just want to know, what is the mechanism by which sand becomes cells? You can discuss the other stuff, Byron, whatever, Halloween, Christmas, whatever cultural manifestations. What is the process that turns dead stuff into living stuff?
But what have you come up with in investigating this process, or asking this question? How does sand turn into matter, to cells? Well, it's obviously matter already. How does it turn into cells?
Yeah. So I think sand turns into cells via a process of continual death, if you like, of the material and rebirth. So you have this finite amount of stuff. The way I think about it is, let's make a sandbox for life. So we've got this box, we've got this sand in there. We're going to put in energy and a selection pressure. So the material aggregates and it creates objects. but then the environment is harsh and it destroys most of the objects. So most objects are gone and they're returned back to the norm. Sad, right? But the entropy is increased, universe is increased. But some objects survive. And those objects that survive are lucky, or whatever happens. But if those objects that survive can actually act in the environment to cause more of them to survive, then you get more complexity. And then just imagine that happens again and again and again. And you have this hierarchy of complexity on complexity on complexity. And you know what? The cell, the biological cell, which is one of the most complicated things we know in the universe, that people say is impossible to have formed without intervention, is merely, or fantastically for me, I'm in awe of it, the process of matter randomly forming aggregates, being killed by the environment, and the stuff that isn't killed gets propagated to the next day, and it can somehow act in the environment to create more of itself by replication or whatever network. And that basically process of creation, destruction, survival, propagation is the core of turning sand into cells, and happens everywhere in the universe. And it's completely obvious if matter wants to become more complicated. And we see on Earth, I mean, look at us, we're so complicated. We have, Elon coming up with memes. We have the people in China coming up with memes. We have humans creating stuff, language, culture, technology, competing, whose electric car is the best, whose chemical is the best. It's fascinating to watch. And so I think that we are actually discovering the physical processes that give rise to biology and our own technology competing with our resources on Earth. Because although Earth is big and there's lots of resources, we have to somehow cooperate together. Whether it's like China saying, well, you're not going to let rare earths go to US, and US goes, okay, we will invent new materials that have rare earth-like properties using carbon. They might do, right? So there's this kind of interplay between this supply and demand, this action and inaction, which what means that life is not special. It's just a very general phenomena of selection.
As you've said a few times throughout our conversation, this chemical combinatorial space is absolutely huge. So what is it that in your lab you're trying to characterize about this process? Is it the types of bonds or structures that facilitate this process of making matter more suitable to persistence and replication? Because I'm sure you're not coming up with a list of chemicals that are more like, well, maybe I'm wrong, that we're more likely to find on Earth that will reproduce in this early stage.
Yeah, so I mean, what we're trying to do is literally come up with like chemical reactors that will mix and match chemicals, change the environment, and then see how things survive over time to capture selection. For me, the process that gives rise to life is very similar to the process that gives rise to a star. Not because, certainly in terms of analogy, because you think about it, if someone says to you, oh, there's stars in the universe, wow, how do they form? You can say, well, hydrogen, gravity, detonation, no explosion, equilibrium. So I say, how's life exist? Well, matter, heterogeneity, energy, survival, and reproduction. And those are the only things you really need. So what I'm trying to create in the lab is those processes working together. Now, to be clear, we are on a path where I think it's working, but I do not think I have the answer. I think I'm observing in the lab, thanks to the collaborations I have and the team I'm working with, evidence that this is indeed the process that gives rise to biology. But I've been wrong more than I'm right. But
So I was going to say, let's just say that you live for 10,000 years, a million years, and you can continue running and iterating upon this series of experiments you've been doing in your research program. Would the ultimate goal be sort of refining until you have this recipe for creating an existence proof that you've figured out the sort of process?
Yeah, I don't know. Actually, that's a really good point. I mean, so sadly, I think I want to live for a long time, but I think I have to make a better fist of it than that. But yeah, right now in my lab, we're designing experiments that will reveal selection and the evidence of selection, how it works, almost like evidence that I think what I'm trying to do is invent gravity, right? Seems a bit weird. In the same way Newton did. And it sounds really weird. Oh God, I'm getting people tell me off. But anyway, I mean, just forget. I want to discover what selection is in the same way that Newton discovered what gravity is. And although Newton did not see a star form, I don't think anyone's going to argue with him then or now that the way that the stars are formed by gravity collapsing material causing nucleation. So I think do something like that would be good. I don't think we need 10,000 years or a million years. I think we need a bit longer. One of my interesting questions is, how long do we need to show chemistry becoming complicated before everyone we talk to, even the strongest skeptic, will go, oh yeah, that is correct. That is the right way it would work. And for me, that's more of a dialogue with society and other skeptics, right? Because one of the things I love about being a scientist is that I'm constantly arguing with colleagues about what are we looking for? What is the experiment? What do they care about? And so I have an idea, but it's almost certainly wrong. But I'm going to try as long as I can. And so, I mean, I actually, if I was going to be really brave, I think we are right now, today, as in what's the date? We're talking about October 2025. I think we're doing experiments right now that have proven that life can emerge from sand. Now, I don't think anyone's going to understand that for maybe 10 or 20 years. And indeed, that process is required, right? Because who am I? I'm just some random chemist shoveling like sand into a. Well, look at that. But I think that the processes, the physical processes, we can understand on our timescale. We don't need 10,000 years or 100,000 years. But in the same way, it took a bit of time when Einstein came up with did it again? Right, Einstein came up with relativity. Everyone would have gone, so what? But when we started throwing satellites into orbit, they started frame dragging and losing their time. Just imagine if we started throwing satellites into space with no idea of relativity, and everyone's like, "Why is the time drifting?" And everyone went, "I had to go, oh, phenomenologically, there's something wrong with gravity."
Mm-hmm.
And it required relativity. So in a way, we've got this similar problem in life, and I think that we just haven't been looking at it correctly. I could be wrong, but that's my view. So, answer your question very long. I don't think we need 10,000 years. I think we just need people to be willing to kind of get behind the question. But right now, there's really weird reasons why chemists aren't getting around the question, sociological reasons, right? I never saw physicists arguing about whether it was an interesting question to ask how stars form. In chemistry, we seem to have chemists arguing about whether the origin of life is a reasonable question or not, which is wild to me. Of course it's reasonable.
There are two sort of directions in which I'd like to head right now. I'm not sure. Maybe they're the same direction, but I want to ask where two things fit into what we've been discussing. One is assembly theory, which I discussed a bit with, well, more than a bit, but with Sarah in the last episode. But another thing is, you started the conversation by talking about an interest in programming. And that brings to mind Chemputation, which is a word I've never said out loud, perhaps a word you coined. I'm not sure. But where do these two things figure into what we've been discussing?
Oh yeah, that's pretty deep. Yeah, so computation is a word I coined. And actually it's kind of embarrassing where I coined it, because I coined this word and then I realized it was a thing. And I got talking to David Deutsch, who was like, yeah, of course it exists. And I was like, okay, you now have to write the theory. I was like, thanks, David. So David Deutsch is a physicist who believes in, he's building a language of physics called constructor theory. It's about transformations that exist that can make stuff happen. And if there's a transformation for something happens. And, I've been talking to David a lot about this, and David doesn't want to talk about assembly theory for sociological reasons. Will about Chemputation. It's so funny.
That's
So let's
funny.
go back. So yeah, because I mean, David's he's a brilliant scientist and a brilliant philosopher and a brilliant thinker. But like everybody, he's human, right? So, he will accept a challenge, but there's some things he doesn't be challenged on. Not because he doesn't agree, like that's 100% wrong. It's just like he only wants to put his effort into a thing that he thinks is important, which is fine. I'm the same, right? We all have egos. Our egos push ourselves in certain ways. But coming to assembly theory is a very simple theory that makes lots of people kind of like happy because it's so obvious, and lots of other people angry because it's so obvious that it can't possibly right. And all assembly theory says at its core is to say, hey, causation is fundamental. That's it. It doesn't say anything else. And what it says is like when you see a complex object on its own, you don't know anything about its history. Like you just say you get beamed into Alpha Centauri. Let's just say you're in Star Trek, Robinson, and you're like there, and Captain Kirk says, just go down to the surface of the planet. You're like, okay. And you go down and someone gives you a complex object. You're like, oh, that's cool. And there's 1,000 of them. You're like, oh, was this made by a life form, or was it randomly created by the laws of physics? And if the number of different parts in the object is high enough, such that random chance can put them together, and the number is large enough, then you will know for sure that it was created by evolutional technology. And that's all assembly theory does. And when Sarah and I kind of invented this theory, we put it out there, the entire universe kind of fell out with us, as it were, all the humans. And they're like, complexity exists. I was like, really? What complexity? And people have been misunderstanding complexity, evolution, and assembly for the last 100 years. Before Freeman Dyson died, I wrote to Freeman, actually, and told him about some stuff I was working on with metal oxides and self-replication. He loved it. And I then, I start off a conversation with Freeman. That's cool. He's a hero. So I then wrote back to him and said, I've got this new idea for complexity. And he wrote back, Dr. Cronin, do not try and work on complexity. It is not worth working on. And for the last 50 years, people have been working on complexity, and all they've found out is that there is no complexity. It's just people being silly or something to that extent. And I was like a bit sad because actually I don't think Freeman is indeed correct. What assembly just says is like, look, if I give you an object, can you somehow interrogate that object to work out how long it took to make it in a kind of like in a kind of no technology environment, just randomly. And number two, how many of those objects can you find in your surroundings? Because if let's take this. If you take this object, we've got this microprocessor here. I can take the part out. I'll do it. I'll take the part out. This is the cartridge I've taken out of this thing, right? The plug in. It's really quite intricate. There's lots of things that clearly have been manufactured. That didn't randomly form, right? But the average physicist would say, hey, there's a probability this could form randomly. And I would tell the average physicist the probability of this forming randomly is precisely zero, not small, zero. And assembly theory just basically explains that. And we really are then able to build a new understanding of what is going on in our physical universe rather than being deluded by probability in physics, which is not correct.
So just to understand this number zero, even if the universe were infinite in spatial extent and in mass, you would still think the probability is zero?
If it was infinite in spatial extent and mass and time, sure, you'd have loads of them. Great. But that's not true, right? And we know the universe is, an infinite is a big number. Um, so the problem is the human mind has the ability to think of infinite, where it doesn't have the ability to deliver infinite. And so, and I've mentioned this, right? Some physicists, like, there's some great physicists out there like Sean Carroll and, Frank Wilczek and Carlo Rovelli that think about these things and timelessness. But I think they're wrong, because time is a finite resource. Because if the infinite universe is all that required, we would have far more interesting things existing than we have now. And I think that the fact that we have interesting things that exist at all is a testament to physical reality and selection. So I think infinite is a very, very hard word, and it never exists. The only thing that's infinite in the universe is our ability to take a given environment, interrogate it in infinite different ways because of the combinatorial complexity. But no, there is not infinite mass, there's not infinite energy, which means we don't have infinite opportunities. And getting that in our heads and kind of conveying that to people is, I think, is quite sobering, because there is a big universe. And Sarah and I have calculated the possibility of developing things in the universe we have now, and it's really small, quite humbling actually. We could be wrong, because there could be an infinite universe hiding behind the finite universe, but it means that we've seen no evidence of an infinite universe and infinite time. We've seen evidence of a finite universe and finite time.
Well, getting into the very basic nuts and bolts of assembly theory, what constitutes a step in assembly?
Yeah, that's great. In assembly theory, an assembly theory is something that I invented. I invented it many years ago, running up some steps in Japan, running back, but long before I would talk to people about it, thinking about what is a step. And I thought I was maybe wrong. But a step is like, what is the minimum amount of information you can specify to connect two objects together in a way? And even then, I'm not sure that's an adequate explanation. But if I have a series of letters or numbers or things I labels, a step would be me deciding to take two of those things and combine them together in a binary fashion. So let me take the letter L and the letter E to make my name Lee. I'm going to make LE. So a step would be the combination of L and E. And then a second step would be the combination of E and LE to make Lee. And so that would be a kind of a way we look at it in terms of a step. A step would be a thing where you actually create some constraint to create an object from the background. But even then, if you ask me some days, I wake up some days, I go, I have no clue what assembly theory is. Who invented it? This is a silly idea. And I'm confused. And I would talk to Sarah about it. She's like, relax, it's okay. It's just hard. I've got this view, you have this view. We bring it together. But it is a non-intuitive idea at the core that suddenly becomes really intuitive, that everyone seems to be understanding. So the axioms of assembly theory are: objects can be broken down into parts that they are composed of, number one. Number two, we can take the objects of the base and combine them together in binary steps and only binary steps. And number three, the object has the shortest path for being produced by the shortest number of those steps together. A great way of looking at it is the word abracadabra, because you say, well, I can take the letters of the base, I'm going to combine them together on a graph. There's 11 letters in abracadabra, but actually, if I combine them from the graph with reuse, I can do it in 7 steps, because you have abracadabra, and the bra was already made earlier when you put them together. So you get a reuse for free, or just one unit. And so it's a bit like about that information that exists in the universe, the memory it creates. So assembly theory says, hey, causation is fundamental, number one. Number two, copy number of the object, the number of objects you can make, indicates the selection's occurred. And number three, there is a causal process at a higher level that allows it to exist in time, and it exists in the environment, which happens to be this selection process that goes there. And that's kind of where the assembly theory came from at the beginning.
What constitutes an object in assembly theory? So what I'm wondering, I mean, I think the example that comes to mind is, would you consider a chess set, so the board and all the pieces, an object above and beyond just the individual pieces and the board?
Yeah, so I think this is the critical question. I think we're going to keep refining over time. But if you were to push me on it now, an object is a thing that I can measure with a technique, number one. Chessboard would work. And equally, if I can also imagine how to dissect that object into the parts, that would be very important, number two, because a molecule is an object. And the thing is, like, this is why I said to you at the beginning, I wish I was a philosopher, because I came up with the idea molecules as objects. I'm like, it's like, what's an object? I don't know. I just made it up, but it seems right. But what I'm doing now is like trying to understand. It's like it is a fundamental problem. And actually, Sarah is writing the philosophy of this right now. She's nailed it. She's great. But an object needs to be distinguishable, and it needs to be kind of it can be broken into parts, into atoms, and it needs to be finite. And that was just what I saw. And the more we applied it, more it works. So chess set is a good example. A chess set is an object, is composed of a board, of all the parts on the board. I can take them off and I can put them together and understand they're constructed. And I have a path to do that. Same way as, say, a molecule of DNA or a computer chip. So an object is a thing that can be interrogated by observation at the correct level to understand how that thing was assembled. And I think that's what my definition of an object is right now. But it needs to be much tighter than that philosophically, right? I mean, way better than me that getting these definitions correct is critical for the next step.
Mm-hmm. There are just a lot of fascinating questions here to me. And on the one hand, I want to say, sure, in our everyday speech, I want to say that a chess set is an object, but in the sense that chemistry or physics wants to get at the world in a mind independent sort of way, if you take all of the pieces of a chessboard and scatter them across the world, sure, I might still think of it as an object, not necessarily a connected object, but it wouldn't really make that much sense to think of it as an object independent of the human mind, since these things are also spatially disparate. I don't know.
Yeah, so no, that's perfect, right? Because objects are things that can be selected on. And so if you took the chess set and scattered it over the world, it'd no longer be an object. Unless you had a super intelligent alien who liked chess. They'll pick up the board and pick up the piece and say, no, we're going to play. Right. And so I think that if the ensemble of atoms can be selected upon, and the ensemble, then it's an object. So I think selection really saves us in that regard. And so for me, I'm completely happy. The invention of assembly theory was an invention that came initially from me. It's not very good. Spoke to one of my students, got a bit better. Spoke to Sarah. She's like, no, let's do it again. Made it better as well. And so the conception was to understand the amount of causation required to make things over time that could also cause things themselves. So if you took your object and spread it out so it couldn't do much, the causal power would go down. And so I think there is an argument, which you had just invented because you asked me the question, I haven't thought about it this way, is that objects have to have causal power in a new way as well. And that may figure in the definition, which is kind of exciting. But, I must admit that this week I wouldn't say I'm depressed on assembly theory. I would just say I don't understand it this week. And that's not for you. It's just like I invent lots of theories all the time, and at times I zoom in and out, and I wake up and go, "What on earth was I talking about?" And then you have the entire internet telling you, "Yes, Lee, this is complete nonsense. What are you talking about?" And what I did, I actually yesterday, as I was talking to one of my team members, and said, "Well, what do I mean?" And like, no, relax. Like, assembly theory is about causation. It's about the number of different parts in your object. I'm like, yeah, I remember that. It's about the number of objects you can count. I was like, yeah, cool, I can remember that. And then it's about the causal, about how you observe it in the environment, how selection builds them, and they can then create networks of things that act on themselves to create bigger combinatorial spaces where you have selection. I was like, that's kind of cool. But for me, I would say for me, I'm so not equipped to be doing theory because I am so I'm so out of my comfort zone. Um,
Mm-hmm.
it's not that I don't feel confident in it. It's just like I just don't know what I'm talking about some days.
Mm-hmm. Yeah. Okay. Well, I'm finding this very interesting, even if you feel like you don't know what you're talking about on some days or in some area. I mean, the reason that I asked, I mean, there are many reasons why I asked what a step is in assembly, is that I just also had some similar sort of philosophical questions. For instance, I don't know how, I told you my last chemistry class was in high school, and I don't know if water is formed when two hydrogen atoms bond to an oxygen atom, or how exactly it works. But if a step is just some sort of chemical connection, that seems very clear cut. Something is or isn't a step. But if it's mere like spatial, like things move closer to each other, then it's kind of going to be vague. Like, how close do the L and the LE and the E have to be together before they become an object?
No,
So that's just another question I was wondering about.
no, that's perfect, and I think you'll really hit the nail on the head because I don't understand it and you do. What I mean is that the chemical bond is a chemical attraction between two things. There is you have to put energy in to break that bond. So yes, the bond is the most important thing in molecular assembly because it does create an association between two things. It's not discretionary. It happens. It's defined by quantum mechanics. So in the water example, it's quite good because if you have O2 and H2, and yes, it is H2, it's not H dot. So you have hydrogen molecules H2 and you have O2. So you have to bring in one O2 together and two H2s, and then you make H2O because each one you have one oxygen molecule, one hydrogen, and so two hydrogens. And so the chemical bond, and this is why I need to learn philosophy because I'm a chemist who's realized that the origin of life, consciousness, and technology is defined by the bond coming from atoms, producing these ensembles, producing matter. And there's no body doing philosophy and chemistry. We're doing philosophy and physics and computer science till the cows come home, and I'm stuck here literally holding the bonds, like holding the baby, going, but what do I do with this? And assembly theory is merely an effort to say, these things become connected. There's an energy that associates in the chemical bond. They're not going to fall apart. So they're not kind of like, a happenstance. They really exist in space. And we can build objects on them, build really elaborate things, complex molecules, ultimately computers, human beings, animals, whatever, stars. And it's based on the chemical bond. And it's fascinating. So an object, if you want to go dig deeper, would be made of atoms connected by bonds with a finite lifetime that wouldn't break, but I could break them into atoms. So if I'm being a chemical chauvinist, I would say an object from my view, it's a collection of atoms bonded together by the chemical bond, and I could basically measure and determine really existed. It wasn't ethereal. I could hold it. I could literally give it to you in a glass vial. If it was, I don't know, caffeine or, sugar or something, right? It's like, here you go, Robinson. Here's my object. There's a molecule in a vial and there's a number of copies. And I think your clarification there is really important because the object isn't a weak association of objects. There has to be an energy that's put them together, and you can't just break them apart arbitrarily. You need energy to break them apart. And that's exactly the definition of a molecule.
Okay, very good, very interesting. One last question that I've been wondering about assembly. So just as a prototypical biological molecule, ATP, do you happen to know off the top of your head its assembly index?
It is 21.
Okay, perfect. And just also helpful, what are some of the steps in the assembly of an ATP molecule?
So ATP contains carbon, nitrogen, oxygen, and phosphorus. And so if you were to take the entire molecule and break it apart, there's lots of ways you could break it apart, but there is a shortest way to get there. So you go at the base. At the base of the tree, you would have phosphorus, nitrogen, oxygen, carbon, right? And you combine them together. And so you could do it in lots of different ways to get to the actual object. But if you think about it, oxygen, phosphorus atom, another oxygen, dimer making the diphosphate, carbon make the ring, make the other ring, add the nitrogen in, and have the sugar in there. And so that would be the way you look at it. You could make a graph taking all those atoms and combining them together. Now, that graph is somewhat arbitrary because you don't know the actual process that built it. All you know is that there was a process that built it because it has 21 steps. And so does that make some sense?
It does make some sense. It does make sense. And the reason that I was asking is I think there are plenty of naturally occurring molecules that have many, many steps. So for instance, I think of like a massive crystal in a geode as it's just very large. There are many steps. And what I'm wondering is there a rule in assembly theory that it only constitutes a new step if it's not like repetition? Or a snowflake, for instance, might have many, many steps. It's a large molecule. So what is it that distinguishes the two in terms of assembly theory?
Yeah, so this allows me to uniquely bring in the assembly equation. So in assembly theory, we define two parameters. We define the assembly index, which is the number of steps to make the molecule, and its copy number. And then we quantify those together to be A, big A. So A is the amount of assembly. And to this day, I'm yet to really adequately explain what A is. And again, it's going to sound rather hubristic because I'm like, A is like it's like gravity, right? It's like it's the amount of selection per unit object per unit time. And so the way I look at it is to say, look, when we talk about the crystal or the snowflake, you can get really high assembly index. But actually, unless you have a more than one copy identical, it doesn't count. So the assembly equation says is basically A is equal to the sum of e to the AI times ni minus 1 over nt. So ni is a copy number, minus 1. So it means say, so ni minus 1. So if you don't have more than one, forget about it, 0 over nt, the equation collapses. So what that means is if you have an object that has an assembly index of 1,000, say, you've got this very interesting diamond you've written all this stuff into, but you only have one object, then that doesn't count to causation. That's just a random happenstance. And so when I built the equation, I actually built the equation looking at this and then inferred the equation from trying to understand physical reality. And for me, this is hard because I'm not a physicist. I don't build equations. Physicists don't build equations. Well, sorry, chemists don't build equations. I was like, shit, I think there's this new feature of reality I need to build. It looks like this and looks like this. This is how reality is. I'm gonna make some math that fits my reality. Because I think a lot of people think that math creates reality, and I'm like, no. And this is why I love listening to your podcast, actually, because you listen. There are lots of people out there like Tim Maudlin, who's like, no. The actual reality is what you observe. Then you then capture that into mathematics and go back. And it's not just Tim, but lots of people. I think that gave me some heart because I'm like, okay, right way to look at it. So when you're looking at your geode and whatever, unless you have identical objects, they do not count. And so the assembly equation just collapses. So it's not about now the number of parts on the graph, it's about the copy number. Because there is this, the thing, if you can have a lightning strike that strikes some sand and makes a shape. My favorite cup here is a very nice, intricate cup. Let's just say a lightning strike produced something that looked like this. Is that an object from design? No, a lightning strike happened to basically, produce an object. Well, if lightning strikes could produce 100 of these, those lightning strikes are no longer random. They are some alien fabricating my cup, right? And so then you are, the copy number is high, the assembly index is high, then we go up the assembly equation. So the assembly equation is the thing that measures selection in reality in the same way that the equation of gravity measures the force between objects in space-time. That realization made me super happy.
Is there a principled reason? So we haven't on Earth found a mine of coffee cups like yours, but is there a principled reason why some other planet elsewhere in the universe with different chemical composition can't naturally have some sort of process that produces a very complicated structure abundantly?
Yes. So this is the thing. If I can convey it correctly, it will be eureka. And if I do it badly, you'll be like, no. So the way you think about it is like the principled reason. So let's just take this cup. This cup has a number of different parts, lots of different parts. Let's say it has 100 different parts. You would say, hey, Lee.
Really quickly, though, what do you mean by, what are the different parts when you refer to a part?
So if you pixels, and things painting on here, and someone's did this bit and that bit. So basically, I said, what objects? So I would clump together an object, join them together, and then put it in to the thing. So I would actually say a number of atoms.
So different molecules, different types of molecules, the black molecules, the whatever goes into ceramic.
Yeah.
And they're bonded together. Okay.
Almost, or you could think about like a screen where I have pixels and I put in the pixels and color them as a color, whatever you want, right? It's just a series of controls. And so the number one resistance I felt with assembly theory at the beginning was people said, I don't believe there isn't a process that could produce a magic molecule with a high assembly. Great, I understand that. But let's go all the way down. Let's start with a mess of atoms. At the base, there's just a mess of atoms. And they're all simple. And so how do you get from simple atoms to a single object in abundance? Unless there's some design. And that is the confounder. That's what, I have argued with some of the most famous chemists on planet Earth over the last 5 years on this. And they all say, but what about this magic? And I'm like, but all the atoms. It's a bit like me saying to you, hey, Robinson, I will take you a whole load of atoms, marbles, ball bearings, whatever. I'm going to glue them together randomly and make an object that's complicated. But if I glue them together, I physically have to have information to glue them together. Unless I glue them together and I happen to make a cup. What is the probability that can happen? And so I think that this is the number one bias that everybody is confounded by in assembly theory. And I think that this is the reason why I'm excited, because I think it's interesting. I was going to say not wrong, but let's just say interesting. That's more humble. So, yeah, so what you're saying, I've got this object, it appears on the planet, it's complicated. But I'm like, but if it's complicated, it needs to have had intention if you've got more than one copy. If it's complicated and there's just only one copy. It's a lightning strike in some sand, and it gives you a beer glass. That's fine. Very happy to have a random beer glass. Well done. You're lucky. But no, if you have copy number and they are identical, then you know it's a product of evolution or technology. And I have been pushing this out there now for about 4 or 5 years, trying to get chemists to push back and give me examples where, because they would say, oh, let's imagine planet A, and the planet A has got all this different crust and chemicals and lightning and stuff, and basically, and we can make this molecule. But I'm like, well, where from? From these building blocks, from carbon, from atoms. How does it make molecule A? It will make molecule A, but molecule A to a trillion. It has to make molecule A in abundance. And what do you do to the process to bias that process to make A in abundance rather than everything else? And that's where everyone falls down.
ATP, you said, has assembly index 21. What is the assembly index, or what are some assembly indices for very complicated but still natural non-alive substances?
So I think some of the amino acids have an assembly index between 3 and 11, and they're found in meteorites all the time. It's really interesting. You have 20 amino acids. 11 of them are really quite simple. I think I forget the number, but I think let's just say 11, between 9 and 11. And they basically are found in meteorites everywhere. They're just simple. But some of the amino acids have an assembly index of 14, 15. And they are not found in meteorites because the combinatorial space is just too large. And and that's, one of my colleagues, a really good colleague, is a lovely man, is like, I can make ATP in my lab without any information. And I'm like, I mean, sure, show me the evidence where you can do it, and that'd be great, but you can't. And it was all confounding. And I think so it's going to take some time, but there's the cutoff seems to be fairly strong. When we did the experiment, I mean, I had the feeling, because it's a bit like, if we played, we should think about what card game we could play where it's completely random, needed some bluffing, or was fairly deterministic. And the random ones are just going to be boring. The deterministic ones are going to be frustrating. The ones where we don't have complete information and we can cause things to happen via selection are the ones where we get non-trivial things to happen. And I think that that's what life does.
Where now does computation come in? And what is computation?
Yeah, computation is such a funny thing. I mean, I kind of have a dual reality, because I was arguing with David Deutsch, actually, the physicist, who's kind of the originator of quantum computing. Well, not the originator. I think he built on Richard Feynman and a few others, but he really formalized it like a Turing machine. And a few years ago, I was like, I want to build a computer to do chemistry. And I realized, oh, it's a computer because it's physical. And then I thought the act of actually doing chemistry similar to computer would be called computation. And the nice thing about computation is I could then write down the mathematical, the calculus of computation. Because right now, chemists, I kind of will put this together, like, what is the temperature, pressure, blah, blah, blah. It's not completely quantified. And so I invented this formalism, if you like, to say, well, can we come up with a programming language for chemistry? Because I was frustrated that chemists can't reproduce each other's work. And they're I was having a parallel life, if you like assembly theory, evolution, everything is kind of, anarchism. And the other life was like, I program everything. Because David is making fun of me on this quite, radically. So computation is merely the process of taking some chemical inputs, some information, and turning them into molecules, and doing it in such a way that it is Turing complete. And because if it's Turing complete, I can then build on it and make it abstract, and then I can make machines at a high level, a bit like you know, well, it's a cybernetic computer, but with chemistry. And so computation is the act of doing that. And I want to be able to make molecules reliably without any ambiguity. So that's computation. It sounds very sexy, but it's really simple. It's like calculation.
So it's sort of simulating chemical processes in the abstract. Is that at all close to what's going on?
No, I think it's more than simulating. It's a bit like, well, let's think about it. If you think in your head, you're going to add 2 + 3. Is that a simulation, or are you actually adding 2 + 3? What computation is literally saying, I'm going to take this molecule and add this molecule with this amount of energy. I know this happens. So the certainty that you have to 2 + 3 is 5 is the same thing as if I take carboxylic acid and add it to amine, that I make an amide if the temperature is high enough. And so it's not really necessarily just a simulation. It is a algebra that connects two numbers or two molecules and makes a new molecule. It's as deterministic as that.
Okay, I'm sorry for being so obtuse, but so are it's actually a physical device that takes chemicals as inputs and gives you an output?
Yeah, you're not being obtuse. I mean, because we're talking about two different things. We're talking about the idea of a Turing machine, which is virtual. So a chemical Turing machine is virtual. A physical Turing machine is a computer that does it. And so, no, I in my lab right now have a physical device that does exactly that. Takes two molecules, adds them together, makes them. So I made the virtual machine to say, look, let's just imagine the language we would need to create a computer, and then go ahead and do it. And we went and did it. So no, you're not being obtuse.
Okay, that's what I
being
mean by simulation.
Yeah, great. Yeah, correct. That's what we do.
Okay, that is so cool. And how does that connect with assembly theory? How are you using? Is it a way of kind of not having to perform very complicated experiments?
So it originally had nothing to do with assembly theory. I just it was kind of weird, and I built computation as a way of coming up with a way of programming chemistry, because I wanted to make a search engine for the origin of life. I wanted to make a Google for chemistry. So I was like, I just want to just do stuff in algebra, just go through. But then and that came first, actually, the search engine. But then when I realized that assembly theory told me that not only do molecules have a measurable complexity, their assembly index, that assembly index is the minimum number of operations is needed to put them together in principle, right, without any other information. And I was like, oh, in a computer, you really want to work out what's the shortest program to make the molecule. And then I realized that computation and assembly theory were going to converge. So that's kind of like, assembly theory is really like, if you say, hey, Lee, can you make this molecule? And I'd be like, okay, what's the assembly index? Oh, it's this. Okay, the number of unit operations, fine. Here's my computer. I can feed the computer the information to make the molecule with this number of steps. Let's see if it works with a high fidelity or some error correction. And so I realized there was a really deep connection between assembly theory and computation in the same way. This might blow your mind, or you might just go, I'm making stuff up. There's a connection between quantum computation and error correction on the qubits. Because when you do a quantum computation, you have to error correct on the qubits, which is not clear that it's going to work, by the way. Quantum computing does not work today. Quantum computation does in my lab, in that I can error correct and make molecules. It's a bit cumbersome, it looks a bit daft, but I can make really complicated molecules with error correction because of what I know from computation. Which for me is like, oh, cool, I can now do information theory on chemistry the same way that physicists have been doing information theory on photons and atoms for the last 30 years, but not actually doing it. They're just doing it in their heads.
Well, we come to another fork in the road, because this is a place where I might be interested in talking about AI and how it functions in this sort of work. or we could talk a bit about aliens and how assembly theory fits into the search for alien life. And I think either way, there's going to be plenty of room for a part two to delve into those topics in greater depth. But what do you think is more
Um,
proximate to what we've been discussing, aliens or
I,
AI?
I think they both work, but I think it might be worth going into AI, and we can see if we get into aliens, or we can do it another day, because I think the alien thing comes naturally out. But AI is something that's super interesting with the way that our current culture is, or certainly mathematical culture is developing. So, I mean,
So,
sorry, go on.
well, before we get into big picture AI stuff, more in connection to what we were just discussing with computation, how does AI help or not help at all with what you're doing in the lab?
So AI, broadly understood, is really important because we can basically connect um, the design of experiment to the data we're collecting to predict the next experiment. And for me, I mean, I've been doing AI for like, I don't know, 40 years. And for me, AI is not magic. It's just basically, if I don't understand my ground truth and I can't compress the equation, right? I just make a rather elongated equation that fits most of my data. And whenever some data falls out, I try and change the equation to account for it. We're a bit like a neural net. The neural nets are like that. The neural nets of this. And so that, but people in the last 5 years and the way that AI has worked, and particularly in the last 18 months, is AI has become a cult. And I'm just like, and it's become a cult not because of anything dramatic. It's become a commercial cult in the same way that, I don't know, Tamagotchis became a cult. I love Tamagotchis. I love them. I would like to hatch them and keep them alive and so on. And I know it's like a little digital device and it's not real. But what's happened is the AI gurus have basically said, no, Tamagotchis are real. And so I feel like I'm living in some kind of AI delusion adjacent to the fact I'm using AI in my science, right? Which is great. AI is very important for science. There's nothing wrong with it. And so we could probably discuss that because I'm really feeling very confused by the propagation of bullshit in the AI sphere. And I don't know. I mean, I've listened to some of your stuff where you had really great conversations with Reid Hoffman and Tyler Cohen, both of which I love a lot. They're great humans, firstly. So they're not wanting to bullshit the world and they have interesting questions. And there's a few others out there where we're just like, what is AI? And there's people just making stuff up.
Well, when you describe it as a cult, I'm wondering then if you're saying both sides of this very public debate, either very pro AI or very terrified about AI, you think they're both kind of spouting steam, and reality is much more deflationary and less exciting than this.
I mean, reality is exciting. I love reality. It's like the best place to be. But absolutely, you're saying so. There's two extremes, right? And I kind of fell out with Eliza on this Yudikowsky, and I listened to your podcast with him. You were super good. It was a great podcast. He was great. I mean, I do. As a thinker, I respect him deeply. Um, as a but he's not willing to debate, which I kind of find a bit sad. So I would take the following stance as a bit boring. So I would say, hey, Robinson, I'm going to tell you, I'm going to invent this technology called AG. And you'd be like, and I'm really worried it's going to kill us. You're like, what's AG, Lee? I was like, it's anti-gravity. And if I invent it, what's going to happen is that everything's going to float away. We're going to have no atmosphere. We'll be floating and, we're going to die. We're like, oh my gosh, that sounds bad. But then if you would say, well, okay, we're worried, but how worried should we be about AG? What is the mechanism of AG? Given I know that basically there's an inverse square law connecting the mass on Earth to the mass in space, and there is curved space-time, whatever you want to look, Newtonian, Einstein. But what Eliza Yudikowsky says, he says, and then you're all going to die. And I'm like, if I fly above the Earth in an aeroplane and look down, most of the Earth is not covered by the internet or humans. It is basically empty. And sure, we could get people to nuke the planet and change the climate, and we might die a bit. But that's really, you'd have to do quite a lot to do that. So my argument would be, in the same way that AG scares me, I don't want to float away. What does the mechanism of AI do? And it turns out it's bullshit. And the same way that Nick Bostrom is spouting bullshit. And I'm calling these guys out because they are not merely raising the alarm, they are literally creating alarmist bullshit. And I don't like that, because as thinkers, we have to be held accountable by what we say. So, Nick Frost on one hand and say they're super intelligent. So like, okay, define super intelligence. Can it think in a different dimension to me? Oh no, it's faster. Well, that's not super intelligence. That's just a fast intelligence, right? It's not on a different level. Same way to Eliza, say, okay, why are we going to die? Oh, the AI will do this, blah, blah, blah. But there's no mechanism. And so what I want to do to these guys in particular, these two, and we'll go to the opposite side because we need to be fair. So the doomers are making stuff up, and it's frankly unforgivable because they are creating a false enemy when there's a real enemy, because AI is dangerous. Then you got AI is going to create infinite abundance. You have Sam Altman and all these guys going, we're all going to live forever and there's infinite energy. And I'm like, okay, that's cool. Where is this infinite energy and living forever? What is the mechanism? So you've got these two random kind of dichotomies, because like I only realized this in the last month, right? Because until then I was like, everyone was really, dancing off and I realized you've got this ridiculous, we're all going to die and we're all going to live forever, create wormholes and fusion. I'm like, this is the most ludicrous outcome, because fusion is hard, energy is hard, abundance is hard. So you got the AI pros saying you're going to get infinite abundance and live forever, and the AI doomers saying you're going to die. I mean, both those things can't be simultaneously possible. So that's, sorry, I'm ranting, but for me, I find it fascinating because I know I'm concerned. I love humanity. I love our culture. I love I love the mystery. The mystery is not done. And for me to say, oh no, we've just invented the printing press, I'm sorry, it's all over. Just like, well, there's no evidence for that.
I love the rant, especially about AI, because I'm very open to hearing whatever any smart person and educated person on the matter has to say about it. But even if we don't take the Eliezer Yudkowsky view as entirely warranted, even the people who are very pro AI, like Tyler and Reed, make very clear that they are nonetheless worried about humans using AI to facilitate our destruction. And the reason that I thought that this might be particularly connected to your work and creating like Chemputation, a Google for chemistry, they're worried about AI being used to create biological weapons. And it seems like your work could possibly be used toward that end if people want to use AI to do this. And I'm wondering how you feel about this concern in particular.
Yeah, I think that's a super important concern to articulate. But I wouldn't just say AI. I would say, so let's draw a line under AI for a sec. We'll come back to it. So I think you've got the nail on the head. AI is just a new technology. It's not going to kill us. It's not going to save us, but it's going to do something else. And what we need to do is interact with it in a way that is allows people to. We want to treat people with integrity because, I came from a retard class at school, right? So I'm like, when people say you're stupid, I'm like, I know. One of the things I think I find really funny is that we assume people are stupid, and then general humans aren't stupid. They're quite smart. They are desperate for meaning, as we all are, and they want to know more, and they're hungry. And so we have a responsibility to each other to have a responsible conversation. Say, oh, what do you think of this? What do you think of that? So the AI thing is a good one. So that's great. When it comes to Chemputation, you're absolutely right. Biological weapons and making chemical weapons is super dangerous, right? There's also the discussion about the origin of COVID, right? Whether you believe in whatever. COVID came from somewhere, It probably came from our farming practices, not genetic engineering, but who knows? Um, and I do feel very concerned about the fact that I'm developing a technology that could be dangerous. But here's a really interesting thing. The chemical technologies we're developing could save so many lives in the future that so many lives, like the fact that the risk of developing them versus the future benefits is easy. Now, it doesn't mean I go, oh, hello, everyone, have my computer, please go and try and make yourself a Novichok or a bomb. What I do is I say, hi, everyone, here's my computer, here's how it works in academia. Here's the information. How do we regulate it? And how does industry, how does science work? How does our regulatory environment work? Because the thing is, my job is not the job of the regulator. My job, you pay me, or not you, but the taxpayer pays me in the universe to just do new stuff. And I want to be a good human being, but how do I know what I'm inventing is going to be good? I don't, right? I could make all sorts of mistakes. So my job is to be open about what I invent, publish it. And so when people talk about the chemical weapons and the dangerous part, I merely say, well, I can do all the stuff I'm doing right now. Sorry, I could do as I could already do. So biological weapons are actually quite hard to make. I mean, AI is not going to accelerate biological weapons. It's really greasy and falls down, and human beings evolve, right? Biology evolves. So I would say that we have time to make mistakes and correct them. And I'll give you an example I love a lot. There was one poor chemist that worked for DuPont who invented CFCs, which did kill the ozone layer, which was bad enough. And then he invented tetraethyl lead, i.e. leaded petrol, which gave everyone a low IQ. One company did this, and they corrected both of it. And what happens when we make mistakes, we correct them. Is there a danger that I will create a computer that destroy humanity? No, I think that's not possible. For good evolutionary reasons. Is it possible that we could create a biological weapon that could kill all life on Earth using AI? No, for very good reasons I'll talk about. So that's not an excuse for me to ignore it, but actually, this idea again goes back to Eliza saying, "Oh, don't do this thing because you could die." Because everyone said, "Oh no, don't create new chemicals to look at chemical space because you might die." Oh, you just invented antiseptic. Thanks for that. Oh no, don't develop new chemicals to look for kind of, killing bacteria. Oh, you discovered penicillin. And if you look at how human beings have created new technologies, if you look at the code of things that could have gone wrong versus what we've done as humans, in for the last 1,000 years, our experimentation has made us live longer, generate more technology, have social media, be conspiracy theorists. The fact we can even conceive of this is a win. So I would say that we have to do three important things. We have to invent, we have to debate about the merit of those inventions, and we have to allow our societies to ask, how do we want to allow those inventions to be used? And I would say, this is where I say, and I'd be interested in your thoughts. I say my job is not to invent regulation. My job is to invent things to be regulated on. And if people want to regulate my inventions, I have won.
My quick thought on that is, so as you know, I'm in law school right now, and I'm so a lot of times the judiciary won't make a decision about something because they'll say, well, this is kind of out of our domain. We should let the legislation do it. But we see what's going on in the legislative system right now in the United States and in Congress, for instance. You can't really count on them to get things done. And so I don't think it's really. I'm not saying that you shouldn't be inventing things, but I don't think that the excuse, and I don't mean that in a pejorative way, that I'll let the legislature deal with it, is really an acceptable excuse. Just because, for instance, I mean, if you develop a computer, and let's just, for argument's sake, assume that it is capable of helping somebody produce a biological weapon, just for argument's sake, you can't fall back on, well, legislation is going to stop terrorists from using it, or legislation is going to stop China or Russia from using it. Best case scenario is legislators in the UK or the United States attempt to get companies in the UK or the United States not to use it.
So, okay, no, I don't agree. I really think that's not correct. So I mean, you're doing law, and the U.S. legislature right now, actually, when it comes to things it decides on, the things you're worried about are all political. Um, but if and when the people's lives were being terminated early because of a thing, they would legislate against it. I'm not talking about edge cases like should we chlorinate chicken or not, or what our food supply looks like. So I think that's one thing to bear in mind. But there's another thing I think is really important. What you said is like, my job is not to. If you said to every scientist or philosopher, be careful what you think and be careful what you make. And you have to censor yourself. Basically, what would happen is you wouldn't do anything new. If you had to legislate what you think and what you make, you would do nothing new. You'd be constantly worried, and the loss of future from humanity would be devastating. And the fact that we have some edge cases in the UK, US, China, wherever, I don't think it's been any different from before, right? I don't think. I mean, what has the US prevented that's killed massive numbers of people? It hasn't. Okay, you have guns, you have arguments about the EPA and some pollution, but broadly speaking, people are healthier and living longer. And actually, we don't let people bring chemical weapons into the precinct. I mean, I'm riffing with you here. I'm trying to work out because I think what you're saying is I want to take 100% seriously because I'm building a technology that misuse is going to kill people. And I don't want that to happen. I mean, a good way, actually, is a good one. There was this airplane that went across the Alps, and the pilot decided to commit suicide. You know, it was like I think Eurowings or something. And the pilot waited until the co-pilot waited until the pilot left the cabin and went to the toilet, and he barricaded. He basically changed the lock, and he set the altimeter to 0. And basically, because he was sad, presumably he committed suicide, and he killed all the people on the plane. And you've thought about that. It's like, shit. If only Boeing or Airbus, depending on whoever it was, had built in a facility to not let that happen, no one would have died. But, if I build a technology that is broadly good for the universe, should I be responsible and legislatively responsible for preventing all the edge cases? And I don't know how to get that balance right yet. All I know is to be bold, be ambitious, and be clear, and let the legislators, and because society pays them, right? And you're saying, oh well, I don't really trust society to get legislators. I think that's a micro problem, same in the UK, that will solve that because people aren't dying because of technology. People are dying because of phenomenology in society, right? And the people are not dying because of technologies that people have developed used badly. People are dying in society because of people refusing to solve social problems, being gun violence. No one is like you. So I guess that's what I'm saying. But I mean, I don't know. Joe, what do you think? Let me throw it around to you. Should I stop developing technology because I'm scared it will be misused?
This is an area where I know so little that I hesitate to make a judgment. And you're much better. So you understand this technology much better than I do.
Yeah, yeah.
And if I were you, and I was very, very certain that the technology could not be used to create a biological weapon that could wipe out humanity, then I wouldn't be worried about it. But if I thought that some very smart terrorist could possibly use the program to develop a weapon that could harm many, many people, then I would certainly be hesitant about continuing doing it. But,
Yeah,
or
but
I would just be as careful as I could about keeping the proprietary information safe.
you're assuming that I know what my technology can do, and I think that's in the first order that's right. Second order that's not right. And secondly, you're assuming that if I keep it secret, people aren't going to catch up, and the more I keep it secret, the more they're going to chase it. So I'll flip it around. So I like it. Number one, my approach is to be as open as possible, so everyone knows what the problems are, so we can immediately go there. I'm not saying we give nukes to everyone, because that's bad. Number one. Number two, one of the things I am doing actually with the computer is I've built a thing called. Do you ever heard of digital rights management for like ebooks and what you do? You
Yeah.
protect encrypting stuff. I've actually made for the computation a chemical digital rights management. So actually, if we make certain molecules that are quite dangerous, just to stop students of other people, we produce a digitally coded certificate so people can't do it with our code. It's just encrypted. They'd actually have to, work with us and demonstrate they have safety protocols. And when people argue and say I'm being, restricted, I'll say, well, do you want your bank account to not be encrypted? And we're like, oh yeah, I don't want no one to steal my money. I was like, it's just all I'm doing is taking encryption protocols you use in online banking and using them to computation. So the good answer to your question is like, hey, actually, we could debate it. Like I say, oh, I want to be an anarchist, but the real answer is we've just developed an encryption protocol where in principle, you cannot hack the system because it has 256 encryption and it's as secure as your bank. So the same people that could break into your bank and steal all your money could break into our computer and try and do bad things. But at least it's a barrier and it allows people to think about it and it allows society to look at the relative merits and demerits. So yeah, you're spot on them. It's spot on there because at the end of the day, we don't know. I do not know what people use my technology for. So it's my job to basically be as responsible as I can in the now but also give people opportunity to explore. How do I do that? Have some controls where we have trust. Trust and controls to people works in our society. We've shown that over the years. Biological weapons have been known for like more than 50 years. No one has knowingly, let's ignore COVID for a second, deployed biological weapons in theater that we know of. So we're being pretty good humans to one another. Chemical weapons have been deployed, and we are not allowing that anymore. So I'm very optimistic about humans being nice to humans because we all want to survive.
I'm very pessimistic about that. I just imagine that as I think that there are a lot of very bad humans, and as technology becomes more accessible, whether because just in general we're more capable of producing biological weapons, or because AI enables people who otherwise wouldn't have the ability to do it, I worry that it is quite plausible. And maybe not in the next 2 years, but 50 years from now, I mean, I don't think we can really imagine what the world is going to be like 50 years from now at the rate that things are changing.
I mean, I'm not sure your pessimism is right. I don't think it's I don't. I think your pessimism is more. I don't think I would rephrase it for you. Say it's not pessimism, it's hesitancy, and maybe you feel responsible. I don't think your pessimism has any evidence from the past. I think humans have been really. Look at how we could have messed up our planet. We are so independent. Where it's wheat, rare earths, milk, air. We're really good. Humans are getting better at being nice to one another because our technology has become more and more interdependent. And so I would say, sure, I don't think you're pessimistic. I'm going to suggest you're cautious. And I think your caution is well placed. And I would argue that I am also cautious but optimistic. And I'm not saying, oh, just trust me. I'm a chemist. I would say I'm aware that there is an issue here, and my job, if you like, is to let's do the following thought experiment. The thought experiment where I don't do any new technologies and prevent others on the future of humanity, versus the one where I just do lots of stuff and make people understand it and do my best to kind of be responsible. There's two futures there. One where I don't do anything, and I'm scared, and I think we should restrain what people can do. And the second one is where I basically say, well, actually, I will do everything I can to create new things, but just let people know what's going on so they can intervene. I think humans always create things. Suppression never works. There are no conspiracies, and that I think my view is that I'm very optimistic about an open society. With China and the US competing on AI, I don't think there's a danger to the future of humanity.
Right. I think that this is a highly complex moral question. And what is interesting here is, okay, if you think the development of this technology is inevitable and it could be used to harm people, but you believe that if you develop it, it would certainly be used to help people, and it could be used to thwart the people who intend to harm us, then again, it would be a question of risk as well. I mean, what is the risk that people will develop it to harm us? What is the risk that people would use your technology to harm us? And what is the risk that your technology, if developed, could help us against people who would harm us? But again, these are all probabilities that I'm certainly not qualified to judge.
Yeah, I mean, you're right. So, I mean, the technology I'm developing with computation is chemical, right? It's not a biological. It's not basically based upon producing living organisms that basically I can spray in the atmosphere, viruses and so on, right? So that's one thing. And so actually doing damage with chemicals is quite hard. You have to have a high concentration of stuff. There was this ridiculous scenario in the UK a few years ago where some alleged Russian spies were building Novichoks, which are basically a kind of nerve agent to kill people, and they mixed them together in the wrong quantities and injured themselves. Because it's really quite hard to kill people with chemicals, right? You have to get them. You have to think about the process. The same like where Eliza Yudikowsky is saying we're going to die. How are we going to die? I mean, ways we can die. We can die through old age. We can die through disease. We can die through asphyxiation. We can die through lack of food or water. They're the only ways we can. Oh, we can die through poisoning. So there's 6 ways we can die. It's quite hard to poison someone, right? It's really hard. You have to really give them some stuff and make them ingest it. So that's one thing. It's really hard to give them biological weaponry. Like I say, the planet's quite big, because what happens is when you start to release a pathogen, it kills things, but that doesn't kill everything. And those are people that are lucky and have the correct genes will evolve beyond it. And I'm not, it's not great for humans, but instantaneous life, right? Evolution has been going on for a very long time. But the fact now we are way beyond this kind of mechanical death. We are in this situation where we have technology and interconnectivity, where we have culture, technology, and biology and move all meshed together, that we have a super dependence on one another. Now, again, I'm not saying that your fears are ill-placed. I'm saying it's really quite hard to disrupt other humans using this, because you have to do so many things simultaneously that I don't think we are able to manipulate it. The only thing I would say, agreeing with you, is on the chemical side, we're not making biologics. We're encrypting stuff. We're working in any jurisdiction we're working with local government, and whether you trust them or not, we were talking about earlier, that's a really interesting stance. And then we have to weigh up the versus discovering penicillin versus not. and I'm on the let's discover penicillin, because here's the killer. Um, um, Here's the philosophical outcome. If me, would you rather I discover something quite nasty, being open, so other people can look at it and go, oh, we'll get the antidote to that, versus someone discovering it and keeping it secret? And I think what you see in science is the reason why open science has progressed and helps humanity survive is you literally are building a immune system in technology. The more edge cases you create is counterintuitive. The more ways you create of killing yourself, the more ways you create of surviving. Where most people think the other way is like, oh my God, I don't want to do that, I'll die. But actually, it's the other way around. And that's why I'm excited about the future.
Well, one aspect or one place where I think your thoughts, it'll be interesting to hear where they connect with some of Eliezer's thoughts, is you're skeptical of agency of AI as we know it having agency. And
Yeah.
Eliezer, when I spoke with him, one of his main fears is that AI will have something like agency. It will sequester itself in a place it cannot be observed and then develop biological weapons and use them against humanity. And let's table for the moment the question of superintelligence and what it means and how it's distinct from fast intelligence. But just what is wrong with the idea of AI developing its own agency?
Oh, yeah, such a good question. It really infuriates me. There are some really great people. I mean, don't get me wrong, I respect Eliza a lot, and also Max Tegmark and all these people, but they are making a fundamental mistake. Absolutely fundamental, which is provably wrong and is philosophically provably wrong. And it's this idea of agency, and this idea about suddenly an AI is going to do a thing. The way I look at it, let me explain what my view of an AI is. A large language model is a little bit like you go to a library, you open up all the books on a random page, you can access all the books and read them, right? And you can read them in a probabilistic fashion. You can read something from them. The meaning comes from the human. The data set is produced by humans with agency. And right now, both Eliezer, Max, all these people are looking for agency, and they do not understand what agency is. And this idea that AIs are going to become sentient is nonsense. It is beyond ridiculous. And I frankly don't understand why they are deluding themselves. It for me is a very frustrating distraction from the real problem in AI, which is authenticated data and authenticated users and bad humans using it to do harm. The AIs are not going to be sentient. And the reason being, the AIs are fixed objects built in silicon. They have not been evolved. They have not gone through 4.3 billion years of the prospect of life or death. They are merely frozen accidents in autonomy, where you and I are continuously updated autonomy, making decisions every second. Do I feed the cat? Do I feed the dog? Do I go out? Do I do this? What goes up? What goes down? And everything else is nonsense.
It doesn't seem like Eliezer's argument hinges on AI having any sort of human-like sentience. It just needs to have a goal. It has to be, as he puts it has to be indifferent to humans and then have a goal that is in conflict with humans.
I don't think I think he is playing a magician's game. The AI doesn't have a goal. The goals all come from the humans. If I built a home defense system with the goal of keeping out an intruder, and I basically had a gun and it would shoot things, that was me as doing it, not the AI. The AIs do not invent anything new. No AI has invented anything new in the history of AI. And the problem, and Eliezer doesn't know what agency is. And so the thing is, the goals come from the humans. And that is a fundamental misunderstanding. He is projecting that out there to generate, the worst case, because he doesn't know what he's talking about. And the best case, to generate fear and control, right? The AIs are Excel sheets with weightings in them. They don't have an agency. They don't exist in the material world. They don't have a fear of death. They don't have a love of life. They are just numbers in a spreadsheet.
Well, Lee, I have really, really enjoyed this conversation. There are so many things that I wanted to discuss that we haven't gotten to. So if you'll come back, I mean, there will certainly be room for a part two, maybe with Sarah or someone else. But thank you so much for joining me from across the pond for this.
Yeah, thank you so much. It's been great to talk to you, and I'm very happy to continue the conversation, merely because I'm sure a lot of things I explained were probably wrong, or we could explore and go deeper. But I really think you're doing a great job in your podcast. I really love listening to them myself. So thank you for having me.